In this video, we are going to go through the module of interactions. Chapter is forces. All right, we're going to look at some exam questions which has come out in previous SA1s, SA2s, and CA1s before. Tom set up the experiment below to find out the type of flat surface will affect. Read this question. I'm going to go through it faster. So read this question. So basically, you have point A, you have point B, you have point C. You have part X, you have part Y, you have part Z. So the complexity in this question is that you've got these 3 points and these 3 parts, and you have this car that's going down. So that's the part that's complex. So let's look at the graph over here. From A to B, so from point A to point B, you need this amount of weight to pull the car in this direction. Now from B to C, there is a change in the middle. So the change you can tell is somewhere over here where there's the biggest change. And at point C, then going forward, you need more weight to pull the car forward. All right, so point B is somewhere in the middle. So this A to B is like a change in the different kind of surface. We have a change of weight that is needed. So let's look at the texture of surface. You have from smooth to rough. Smooth is glass, then carpet. Rough is sandpaper. So let's look at the question. Based on the information above, answer the following questions. Identify the type of surface that parts X, Y, and Z could have been covered with. Alright, so important thing, they're looking for part X, Y, and Z. So type of surface, glass is the smoother, so therefore glass will need the least weight, and sandpaper is the roughest, and they will need the most weight. All right, so least weight is from A to B. So from A to B is the least weight, therefore part X is the least weight, which is here, part X. Part sandpaper is the most weight, so if you look at this part is the most weight, therefore it is over at part point C, which is this part, which is part Z, is the most weight, which is sandpaper. And wait, am I got it? Oh, wait a minute, got it a bit wrong. Sorry. Let's remove this. Let's come back. So again, glass is the smoothest surface, so you need the least weight. Least weight is actually here. Okay, I got it wrong. So least weight is in between here, so it's actually part Y. So Y is the least weight that is needed, and then the one that's above the least weight, which is over this one, is the one in the middle, which is carpeted surface. All right, so carpeted surface. So carpeted surface is on part which is from A to B, which is part X. So it's YX, and therefore part Z over here is the sandpaper surface because it needs the most weight. If you look at part Z over here, it needs the most weight, so therefore it is the sandpaper surface. Alright, so for this question, be very careful with all the parts, all the all the points, and looking at the glass and carpeted and smooth and rough. There's a lot of information here for you to go through, for you to think about. And the important thing is to write out all the surfaces and all the parts. What you find is the least weight, and what you find is the most weight. So write down your analysis of all the information that's given. That will make it easier for you to solve this question. Tom discovered that fewer weights were needed to move the toy car when he poured some water on a glass surface. Explain why this is so. Okay, this is a very standard question in this chapter. So it's always water acts as a lubricant. You have to remember this phrase. Alright, it's always water acts as a lubricant. It reduces friction between the two surfaces. So it's either between the toy car and the glass, or between the wheel and the glass, or between the shoe and the table, or whatever. It always reduces friction between the two surfaces. Okay, so in this case, it is the toy car and the glass. All right, therefore you need So fewer weights, right? So therefore reduce friction. Therefore you need lesser weights to move. All right, because water always acting as a lubricant, reduce the friction between the two surfaces. Then you need lesser weights to move. You have to remember this phrase and this phrase. All right, reduce friction between the two surfaces. Name the forces acting on a toy car when it is moving. So forces, there will be a few forces acting on it. One of them is the gravitational force acting on it down. The other one is the one behind, the frictional force. This is the frictional force. This is the gravitational force. And the other one is the one in front that pushes it in front, which is the pulling force of the weight. All right. So these are the three forces: frictional force, gravitational force, and the pulling force of the weight. The diagram below shows a fruit falling from a tree to the ground. At which point does gravity act on the fruit? Okay, so from here to here, at all points, all right, gravity acts at all points. All right. Let me just rub this away. So gravity acts at all points, at wherever you are, there will always be gravitational force on you. So there is gravity acting on this. When the apple drop here, there's gravity here. Apple here, there's gravity here. There's also gravity here. Okay, so the gravity acts at A, B, C, and D, which is all points on the fruit. So Ming conducted an experiment. Okay, again, read this question. All right, pause the video and read this question. So she wants to find, some kind of friction. So again, you need to know this is some kind of friction experiment. So there are different kinds of floor. This is your changed variable. All right, record the height. So record the height at the ramp at which the shoes start to height. Also, the height of the ramp is your measured variable. So everything else should remain the same except your changed variable. So it's the type of shoe, the ramp, the height, everything else. Which of the variables below should be kept the same to ensure a fair test? Again, I say the only change should be the changed variable, which is the floor covering. So this one should be a changed variable, so it should not be kept the same. Type of shoe should be the same. Initial height of the ramp should be the same. Length of the ramp should be the same. So it's A, C, and D. Which of the following statements about forces are correct? The further an object is from Earth, the smaller is its mass. This is wrong. The mass is the amount of substance in your body, or in a body, or in a thing. So it doesn't change. It doesn't change no matter where you are. But the weight will change, because weight is the gravitational force acting on you, or acting on the body. So the further an object is from Earth, the smaller is the mass. Nope. The correct statement is the same. The mass is the same. All right. The mass is the same. An object with a smaller mass has a smaller gravitational force acting on it. This is correct. All right. So if you have a smaller mass, you have a smaller gravitational force. Larger mass, you have more substance in your body. You have more gravitational force acting on you. An object which is thrown upwards will eventually fall down due to the pull of gravity. This is also correct, all right? Because like I said, if you throw something upwards, it will eventually come down, because gravity is acting at all points. It's just that the force, the upward force, is going to be lesser than the downward force. The amount of force needed to lift an object depends on the size of the object. So this is wrong. It doesn't depend on the size. It depends on the weight of the object. All right. So the heavier the object, the more force you need to lift it. The lighter the object, the less force you need to lift it. So the answer is B and C, number 2. Kyler conducted an experiment in which he released the same block. Okay, so same thing, something to do with friction. So you release something from the top to come down. You need the longer the time it takes to reach below, the higher the friction. All right, or the longer the distance it travels, the lower the friction. Okay, so this is a relationship that you must understand. The longer time it takes to come down, the greater the friction. Longer distance you can travel, so you can travel a long distance until here, then the lesser the friction. So for this question, it's in terms of time. So time taken, 10, 20, 30. Draw your ramp of friction, all right? So the least friction to the most friction. So 10 seconds, 20 seconds, 30 seconds, time to slide down 30 seconds. So this is actually the most friction. All right, so this is C. B is the middle, and A is the least friction because it slides down the fastest. So what can Kyler conclude about ramp A? So what can he say about ramp A? There are a few things. So ramp A is over here. So ramp A has the least friction. All right. So when I see the word explain, what can Kyler conclude, or what can I say about this? So basically, with the least friction, what other things can I assume about this this ramp? So if it has the least friction, I can also assume it is the smoothest among all. And I can also conclude that there is the least frictional force, all right, or least opposing force pushing the thing back, right? So these are some of the things I can conclude. So conclude is again based on what you see. What are some of your, if you apply your scientific knowledge into it, what are some things you can say about this this observation that you make? Kyler's parents brought him to the water play park, played on the water thing, took 3 minutes to get from the top to the bottom. On the second ride, more water flowed down the slide. So he noticed that more water flowed down the slide. As a result, Kyler only took 2 minutes to reach the bottom. So why did Kyler take a shorter time? Because there was more water. All right. So again, explain, right? So there was more water, and then the last thing, it's shorter time. So end of it is shorter time, and in between is your scientific explanation. All right, so there's more water, and water acts as a lubricant. All right, this one you have to remember, and because it acts as a lubricant, it reduces the friction between Kyler and the water slide so that you can go faster. All right, so reduce friction, you can go faster, and therefore it takes a shorter time to reach the bottom. Okay, so again, there's an initial condition, there's a final condition, and you have to give your explanation in between as to why this is happening. So another key thing that you need to remember from this question is that water acts as a lubricant, and it reduces friction between the two surfaces. The two surfaces now is actually Kyler and the water slide, and therefore they can go faster. Okay, so remember this: water acts as a lubricant. Repeat after me: water acts as a lubricant, and it reduces friction between the two surfaces. Study the diagrams below carefully. In some countries, some drivers may fit snow chains. All right, so this is just a normal wheel over here. This is a normal wheel. This is one with a snow chain. All right, so I draw out the chains for you to see. The snow chains are basically just chains that go around the wheel. All right. So average speed with snow chains is 40. Average speed without snow chains is 70. Which of the following best explain about the use of snow chains during the winter season? Reduce friction between the wheel and the road surface. No, the snow chains will increase the friction because it increases the surface area, and also it has these little bumps because it covers the wheel, right? So there's these little bumps, and these bumps increases the frictional force. The chains increase friction between the wheel and the road surface. This is correct. The chains cause the car to move at a slower speed. This is also correct. The chains cause the car to move at a faster speed. This is wrong. It causes the car to move at a slower speed because it cannot go too fast. Otherwise, you keep bumping, so it moves slower. So the answer is B and C, number 2. So I conducted an experiment to find out different types of lubricants. Again, distance. So increase in distance is reduce in frictional force. The further it travels, the lower the frictional force. The same amount of lubricant was applied, the wooden block was pushed. So type of lubricant, you have X, Y, and Z. 3 attempts altogether, 30 plus, 40 plus, 20 plus. Let's look at the question. Which of the lubricants X, Y, Z is the best? Explain your answer. So best lubricant means lowest frictional force, which means greatest distance. Look at the distance, which is Y. All right. So why is lubricant Y the best? Because the wooden block. So again, right, you say this is the best, so this is the best. So the final condition is the best. So the wooden block travel furthest. All right, which means the lubricant Y reduce the most friction. All right, is there anything else you can write? And therefore it is the best. So in this question you have the which of the lubricants is the best, why, and the state why is it the best. So the final condition or the final state is that you have to say is the best. So the first thing you say is the wooden block travel the furthest. So what if the wooden block travel the furthest? So it means why reduce the most friction, and that's what the job of a lubricant is supposed to do. You're supposed to reduce friction. In an accident, a lorry spilled some oil onto the road. Explain why this will be a danger. All right, so spill oil. They need to explain. So there'll be some scientific explanations here, and at last it will be a danger over here. So when you spill the oil, let's think about it. So what if you spill the oil? There will be reduce in the friction because oil is a lubricant. All right. So what if there's a reduction in friction when the cars brake? They cannot stop or take a longer distance to stop. All right. So longer distance to stop, and therefore they will have accidents, or they will lose control of the vehicle, and therefore this is dangerous to other drivers traveling on the road. Okay, so do you see that there's an initial condition which is spilled oil? The lorry spilled some oil. Explain why this is a danger. So when you say danger, so you write down this is a danger at the last state, and in between here is your scientific explanations. Constantly ask yourself, so what? All right, so what? So spill oil. So what if I spill oil? There will be reduced friction, you can say, on the road. And so what if there's reduced friction on the road? Because oil is a lubricant, sorry. So what if there's reduced friction? When the cars brake, they cannot stop in time, or they take a longer distance to stop. So what if they take a longer distance to stop? So accidents will happen, they will lose control. So what if there's that? Then it's dangerous. Okay. So have your first state, have your final state written here. In between is your scientific explanation. Ethan designed a device to clean both sides of his window. So this is the exterior, and this is the interior. There are some sponges over here, plastic holders. Identify all the forces acting on the device as Ethan starts to move it, to clean it. So all the forces, so this is the gravitational force. All right, and if you are going up and down, there will always be a frictional force that's acting on it, and then that's attracting each other. So there is a magnetic force. All right, so these are the three forces: the frictional force, gravitational force, and magnetic force. Next, Ethan dipped the sponges in water. He tried to put the device on the window panes, but it slid down. Explain why that happened. So again, so explain why it slid down. So that's the final state. Dip the sponges in water. So dipped in water is the initial state. So dipped in water, again, the very famous phrase for this chapter, water, I'm going to write it out, water acts as a lubricant. All right, and it will reduce friction between the window and the sponge. All right, So always remember this: water acts as a lubricant. It will reduce the friction between the window and the sponge. So what if it reduces the friction between the windows and the sponge? So what? So the gravitational force is now greater than the frictional force. All right. So gravitational force is now greater or more than the frictional force, and therefore it will cause the sponge to slide down. All right. So do you see how I answer it? So there's always the initial state, which is dipped in water. Next, Ethan dipped the sponge in water. So I just write dip in water. You try to put a device, but it slid down. Explain why that happened. So whatever you need to explain is always the last. So slide down right here. Slide down. And in between will be a scientific experiment. So dip in water. Water acts as a lubricant. It decreases in friction between the window and the sponge. And then after that, so what if it decreases in friction? Then the gravitational force is greater than the frictional force, and therefore it will cause the what do you call this, plastic holder or this window washer to slide down.